So we are going to get some equations like this one where there is a sine and a cos. Now, technically, if you just knew something with two different variables, sine and cos is sort of like solving an equation with x and y. If I said, solve x plus y equals 2, well, there's a bunch of answers that work. Could it be 1 and 1? It could be 0 and 2. There's a bunch of different answers because you have two variables. And last year, you did systems of equations. And one of the things you learned in systems of equations is that if you have an equation with two things you don't know, you can't solve it. But if you have two equations, so if I also told you that y was equal to x plus 3, then you could solve this. Do you remember that? Doing two equations with two unknowns, and then you could either substitute or eliminate to solve for it? Well, we're going to get those same kind of questions here as well, but this time they're only going to give you one equation and expect you to know one of the big ideas. And one of the big ideas is that sine squared plus cos squared equals 1. With that big idea, you could get sine squared all by itself, or you could get cos squared all by itself on one side of an equation. Does that make sense what I did? Just rearranging that equation. I subtracted cos squared on both sides for the first one. I subtracted sine squared on both sides for the second one. What does that mean? Well, in our equation, we have negative 3 sine theta minus cos squared theta minus 3 equals 0. I can replace this cos squared with 1 minus sine squared. Because cos squared is equal to 1 minus sine squared, I can do a substitution. What that does is that rewrites, and I'll put it in brackets because I have more than one thing and that negative would get distributed. Anytime you substitute something in for something else, it makes sense to put it in brackets, especially if it's a big thing that you're substituting in, because in this case, that negative sign will get distributed. We're going to get negative 3 sine theta minus 1 plus sine squared theta minus 3 equals 0. So all we've done so far is change our initial question, which was here, which had sine and cos, which we're not able to solve for because we can't get sine by itself or cos by itself, to an equation that just has one of those functions, just sine in this case. Can you see that this is a quadratic? It's got something squared. So we can rearrange this. Whenever we're solving something with something squared, we always wrote the squared first. Negative 1 and negative 3, those are like terms. So let's write it this way so we can think about factoring it. Now, it's got to be sine and sine, right? That's the only way that you can get sine squared. Now, the last numbers can be 4 and 1 or 2 and 2. But in order to get a 3, you're going to have to use 4 and 1. The 4 will have to be negative. The 1 would have to be positive. Now that we've factored it, and it's equal to 0. We're multiplying two things equal to 0. That means either this one is equal to 0, in which case sine theta would equal 4, or this one is equal to 0, in which case sine of theta would equal negative 1. Are any of those, none of those, both of those on your unit circle? Sine of theta equals negative 1. When do we have the y coordinate at negative 1? 270 degrees, and since this question is done in radians, I think all of these ones in example 3 are from 0 to 2 pi. So that would be 3 pi over 2. Is 4 on your unit circle? No. So when things aren't on your unit circle, you would normally think, oh, then I need to do it the old way with my calculator. So you would take out your calculator and find your reference angle. I'd like you to try that, and I want you to see what happens. All right, so we're trying it on our calculators, and we're getting a bunch of errors. Error domain, error problem. What's wrong? Why is that giving us an error? Well, it's positive 4, but who said that above 1 thing? Yes. Our sine ratio is opposite over hypotenuse, right? If we have opposite over hypotenuse look like this, you can't make a triangle with that because you can't have the hypotenuse is always the longest side. So you can't have the opposite side be larger than your hypotenuse. And so this one would be a non-calculator question on the final exam. They would expect you to know that when you get sine or cos of something bigger than 1, that that's not going to be possible. So what you would do here is you would say no solution or not possible, something that indicates that you know that there's no solution there. If you leave it blank because there's no solution but don't say anything, you will lose marks for clarity. You have to show that you know that that there's no solution to that question. So our only answer, all that work, and we only get one answer. It's only 3 pi over 2. All right, part E. It's a quadratic, so we make one side equal to 0. And I'm going to show you some techniques for factoring here. So you could use your grouping techniques from the past, but I'd like to see if you could go directly to this. Now this one is a hard one because if we look at our first thing, 6 sine squared, there's more than one option. Can you see that it could be 6 sine and sine or 3 sine and 2 sine? So this makes it harder because we have more than one option. We don't know for sure what it's going to be. When I don't know for sure what it's going to be, I don't work with my first one. I look at my last one and I see, does my last one tell me for sure what it should be? It has to be 1 and 1. So I can start with that. And once you have one thing down, now when you go to put your first ones in and think about working with your inside ones and your outside ones, remember they have to make 1. Should I use 3 and 2 or 6 and 1? I should use 3 and 2. Because if I use 3 and 2, my outside's 3, my inside's 2. Can that ever make 1? Yes, if I'm subtracting. My outside would have to be positive. My inside would have to be negative. And sure enough, we're going to get 6 sine squared. We're going to get plus sine theta. We're going to get minus 1. So on this question, once we split it up, first of all, you're going to get really good. You're probably already really good at these. But in the first one, what's sine theta equal to? If it's equal to 0, 1/3. You'd move the 1 over and divide by 3. What's sine theta equal to here? Negative 1/2. Either of those on our pi plate? Yes, the 1/2. What family? Pi over 6. What quadrants? Quadrant 3, because it's negative. And quadrant 4. Excellent. Is 1/3 on our pie plate? No. Okay. So we're going to have to go to our calculator. We find our reference angle by doing sine inverse. You know you've been a math teacher too long. Is that what it is in radians? Okay. So we get our reference angle in radians, and now sine is positive, so our answer in quadrant 1 will be the same as our reference angle. And our answer in quadrant 2 would be pi minus our reference angle. And so that part would be all calculator. It's kind of scary when you remember things that you really shouldn't remember, like sine inverse of 1/3. I wonder how long it would take for me not doing math before someone could ask me and I wouldn't remember that anymore. Not sure. So this one is going to be a calculator question on your exam, because you know part of it you could do without your calculator, but this half you wouldn't be able to do. Do you guys have space for one more? For F? No? Yes? Maybe? On the back side? And find some space somewhere, because I want to show you one more. And we'll do the same thing, solve for theta between 0 and 2 pi. Now, a couple of things I wanted to show with this one. One, for tan, like sine and cos have to be between 0 and 1, but tan, it can be bigger than 1. So that's one thing I wanted to show. The other thing that I wanted to show you with this one is you're looking at it right now, and I can see some of you are trying to factor it, and you can't. So I specifically chose one that can't be factored. Now, on your formula sheet, you have your quadratic formula. And this solves for x, but we don't have an x in here. What would we be solving for? We'd be solving for tan. So we could write that tan of theta is equal to -3 plus or minus the square root of 3 squared, which is 9, minus 4ac, which will end up being plus 28, over 2 times a, which will be over 2. So we're for sure going to need our calculator here. We're going to get 2 answers for tan theta. So when we do -3 plus the square root of 37 over 2, we get one answer that's 1.54. Oh, I want to show you a couple. It's nice to have a couple tricks on your calculator. So I'm going to show you a couple things. First of all, for this one, since we have more than one thing on top, it's going to be nicer if we use the fraction button. And we can write -3. And attempt to write -3. -3 plus the square root of 37 divided by 2. So there's our first answer. And our second answer is when we're going to subtract. So you could retype in everything, although above your enter button is an entry button. If you go second, enter, it retypes what you had before. You can also get what you've retyped what you had before by moving your arrow keys up and clicking on something. But what's nice is if you retype what you had before, you can just go back to where the plus sign is, replace it with a minus sign, and we've got our other answer, negative 4.54. So we've got two values for tan. And so what this means, I mean, I've written them out this way. I'm going to just write them out separate here. Tan theta is 1.54. That's one answer. And the other answer is tan of theta is equal to negative 4.54. Are either of those values on our unit circle? Of course not. Anytime that you're going to have to use your quadratic formula, and it is not a nice number that goes into it, then you're going to know that those values aren't on your unit circle. But we still need to find our reference angle for both of these. And when finding our reference angle, you could draw a triangle if you like, but a reference angle, tan inverse, I'm going to go up and click on my first answer so I have all those decimal places. There's my first answer. There's my reference angle. I'll make sure that my mode is in radians, and it is. So our reference angle for the first one, 0.995. So what does that mean for our answers? Our first one is positive in quadrant 1 and quadrant 3 for tan. So in quadrant 1, we'll get 0.995. In quadrant 3, if you think about it, you would have to do pi plus our reference angle. So I'll just go back and push enter on that and find out my other answer is 4.14. Those would be my two answers for the first one. For my second angle, I want to go tan inverse, and I'm going to go steal this answer from before. What did I do wrong? I used the negative. So stealing that answer from before was good because I kept all those decimal places, but I used the negative. That is very tempting to do, so we're going to retype that, and I'm just going to go through and delete that negative because a reference angle, there we go. A reference angle is always positive. For tangent, when you do tangent of the negative angle, and for sine, when you do sine of the negative angle, your answer will just come up as the negative reference angle. But for cos, it will come up with a completely different answer. So we have to be careful that we always do our reference angle of the positive values. And so now we know that our reference angle here is 1.35. Since it's negative, it'll be in quadrant 2. So in quadrant 2, we go pi minus this answer, 1.78. And in quadrant 4, we'd go 2 pi minus that reference angle and get 4.93. I did that without drawing pictures. Okay, so now we're moving along a little bit, and we did some things without drawing pictures. We had to remember that when we found our reference angles, we dealt with only the positive values. If you wanted to draw these pictures, you could. You could make tan theta equal this over 1. You could make tan theta equal this over 1. And you could say, I know tan is positive in quadrant 1 and quadrant 3. Label your reference angles. Label your sides. You know that it's going to be opposite over adjacent. And you could make a triangle. See your picture of your reference angle and then be able to say that makes sense why this one's 0.995 and this one is 3.14 plus 0.995 or 4.14. So you could draw your triangles if that really helps you visualize where they are and how to find those reference angles.